All right, here we go. So, like I said in class, I'm going to be explaining the AP question that we didn't have a chance to do yesterday. So, this is question number 2 on your paper that you got yesterday. We did question 1 in class. All right, so this is a no calculator section, which means you're going to have pi in your answer. It is a question from the AP Calculus 1990 test, and it's from Calculus AB, which is the level that a lot of your friends are taking. So let's start with what we're given. We're given that the radius r of a sphere is increasing at a constant rate of 0.04 centimeters per second. When they give you an information like this before the ABC, that means that this is probably going to be information that's going to be used throughout the problem. So in all of the parts of the problem, we already know that the dr over dt is going to equal 0.04 centimeters per second. Now, the reason why we're doing AP questions is one of the great things about AP questions is it forces you to really think about all of the information that you've been given in the problem, in addition to kind of the obvious things. So it's not just like, oh, you are given this and this, so of course the answer is going to be this. You have to think, what do I know from before? Or what can I figure out from the information that I'm given? And so the different parts aren't always given to you right away. All right, so that's why we're doing an AP question now, and we're going to be doing an AP question tomorrow. So let's figure out question A. All right, so like I said, we know that dr over dt equals 0.04 centimeters per second. That's something that's not going to change. Let's look at A. At the time when the radius of the sphere is 10 centimeters, what is the rate of increase of its volume? So again, we already know that the shape is a sphere. The way I draw a sphere is I draw a circle, and I draw kind of almost like an eye. And what that shows is that the circle is round and it's like a ball instead of being a flat circle. So I have this sphere. I'm going to label that with R. Let's do the given and the find. Given, find. So I'm given that dr over dt equals 0.04. Sorry, that looks like a negative. Centimeters per second. I want to find what is the rate of increase of its volume. Okay, so I want to find dV over dt. And I know the units for that are centimeters cubed per second. I want to figure that out when R equals 10. Now, in this problem, the equation is pretty easy because they give it to you, right? They give you a big hint right there. V equals 4 over 3 pi r cubed. So let's just take the derivative of that with respect to t. dV over dt equals 4 pi r squared times, and don't forget this part, dr over dt. Now remember, this is a non-calculator question, so I'm doing it without a calculator as well. I know you're very impressed. R is 10, and dr over dt, of course, is 0.04. So 10 squared is 100. 100 times 0.04 is 4. 4 times 4 is 16. So I've got 16 pi cubic centimeters per second. So to write our answer in a complete sentence, the volume is increasing. Ooh, that's a G right there. At a rate of 16 pi cubic centimeters per second. Ta-da! So let's go now to question number 2. Now, the tricky thing about this question is that you might not even really understand what the question, like what it looks like, right? So let me read the question. At the time when the volume of the sphere is 36 pi cubic centimeters, okay, so we're still talking about a sphere, what is the rate of increase of the area of a cross section through the center of the sphere? Wow, that's a lot of ofs and throughs and things like that. So let me show you a picture of what it means to do a cross section through the center of a sphere. So let me see if I can bring that up right now. So this is what it looks like to take a cross section through the center of a sphere. That means that you're going to take like a flat thing and you're just going to cut it straight through the middle of the sphere. Now, if we do that, what kind of shape do you think that we get? If you answered that we would get a circle, then congratulations, that's exactly what we get. So if we cut through the middle of a sphere, then what we get is a circle. And just like any other circle, we of course have a radius, right? Which is right over here. And we have, of course, a center of the circle. That's not as important. The radius is more important. So basically, we have a normal circle. And that is what they want to know the rate of increase of the area of. Okay? So back to this problem. So actually, when I draw the picture for this, I'm not going to draw a sphere. I'm actually just going to draw a regular circle. That's not very helpful. So let me draw a regular circle with radius r. Okay, so I want to know what the rate of increase is of the area of this thing, because this is the cross section through the center of the sphere, right? So let's write down again what I'm given. What I'm given, don't forget this, dr over dt still equals 0.04 centimeters per second. It's nice to have that because looks like I don't really have any other numbers I can use except for this. I'm not quite sure how to use this yet. And I want to find dA over dt. Now, you might be saying, Miss Yamatin, what are you going to do with that 36 pi? And the answer is, I don't know. I don't know how to use it yet. So, let me just do the other steps. I know I want to write an equation. I know that it's the area of a circle. So the equation has to be A equals pi r squared. Now I'm going to take the derivative with respect to A. So that's dA over dt equals 2 pi r dr over dt. Now, I'm looking at this and I'm thinking, wait a minute, I know dr over dt, that's 0.04, but I don't know r. So let me look back at this information that I was given. That one, this one right here. This one, I'm trying to draw it. Okay, here we go. 36 pi cubic centimeters. And let's see if we can use that to figure out r. So let me just go down here for just a moment. So I know that the volume is 36 pi. I also know that the equation for the volume is 4/3 pi r cubed. So that equals 36 pi. Oh, wait a minute. If I have this left side and the right side, I can figure out r. And I do. And the answer is that r equals 3. Hopefully that's what you got. So let me plug that into my equation over here. So that means that's 2 pi r is 3 and dr over dt equals 0.04. So of course my answer is that, let's say 2 times 3 is 6. 6 times 0.04 is 0.24 pi. Oops, and I forgot to write the units in my find. It's area, so it should be centimeters squared per second. So this is centimeters squared per second. So my final answer is that the area is increasing at a rate of 0.24 pi centimeters squared per second. All right, but I have one more part to do. All right, so here we go with the last part of the problem. It says, at the time when the volume and the radius of the sphere are increasing at the same numerical rate, okay, what is the radius? So it sounds like we're talking again about a sphere. Let me write down my given and my find. So it's saying, what is the radius? I see that question right there. So it looks like I want to find r. Right? But what am I given? It says when the volume and the radius are increasing at the same rate. Oh, so it looks like what it's saying is that dv over dt equals dr over dt, but we also know that that equals 0.04. So it looks like that's what I'm given. And I'm thinking I have the volume in my question, I have the radius of my question. So the easiest equation to use seems like V equals 4/3 pi r cubed again. So let's take the derivative of that. dv over dt equals 4 pi r squared dr over dt. Okay. Oh, wait, dv over dt and dr over dt are both 0.04. So that's this, 0.04. All right, so let's see, that's on both sides, so that means I can cancel that out. So let me do that. Let me cancel that out. Right? Now remember, when you cancel stuff like that out, especially on the left side, I don't just have 0. What I have is 1. So I have 1 equals 4 pi r squared. So that means r squared equals 1 over 4 pi. Get my equal sign to show up. So now what I want to do is I want to make sure that the opposite of a square is going to be square root. So I'm going to square root both sides. Right? Square root both sides. Now, usually when I square root both sides, I get two answers. I get plus, minus. But since r is a real distance on the sphere, I know that I don't have to worry about my negative answer. So my answer looks like it's going to be r equals 1 over square root of 4 pi, which I'm going to simplify as 1 over 2 square root pi. Okay, and let me simplify one more step and write an answer on the next page. All right, so to be perfectly honest with you, the AP actually does accept 1 over 2 square root pi, but who cares about the AP? Let's make this answer better. Let's rationalize that denominator, and let's make it square root of pi over 2 pi centimeters. So we can say the radius is square root of pi over 2 pi centimeters. Yes, and I'm under 15 minutes. Goodbye.